Welcome to the museum, guys. Today we're going to be performing a sheep brain dissection demonstration. Basically, we're going to take a real sheep's brain and we're going to begin to take it apart and have a better look at what's going on the inside of the brain. We're using a sheep's brain because the parts of a sheep's brain, they're pretty close to the parts of a human brain. Secondly, it's much easier to get a sheep's brain to do this with and a little more difficult to find a human brain to pull it off with. There's no blood here, so it's not or I personally don't consider it gross or disgusting or anything like that. Let's begin by taking a look at one of these models. This is a model of a human brain cell. We call a human brain cell a neuron, and our brains are made up of anywhere from 10 billion of these neurons to as many as 100 billion neurons or brain cells. This part of the neuron would be wrapped in something white inside the human brain known as a myelinated sheath. This forms what we call the white matter in the brain. This area of the brain, the parts that look like the antlers of a reindeer, these are referred to as dendrites. And dendrites reach out to neighboring neurons or brain cells and make connections. These connections form the pathways for messages to pass from one brain cell to the next and to the next. The more connections a neuron has to other neurons, the faster we can pass a message, which becomes important in the way the body's put together. The areas with the dendrites form what we call the gray matter of the brain. So remember, we're going to have white matter in the brain, and we're also going to have gray matter in the brain. Now, taking a look at this model, it'll help us better understand the three main divisions of the brain. The largest portion of the brain is called the cerebrum. It's responsible for thinking, your five senses. Dreams take place in this portion of your brain. Emotions, language, all of this is controlled by the cerebrum. Then towards the back of our head, we have a smaller portion of the brain that's called the cerebellum. The cerebellum is responsible for balance and coordination. It helps us coordinate all of our voluntary muscle movements. It helps us do activities like hit a baseball or ride a bicycle or even swim. And last but not least, we have what is referred to as the medulla, or we can call it the medulla oblongata, or sometimes it's referred to as the brainstem. Usually, any of those three names, the medulla oblongata, or the brainstem, usually all refer to this portion of the brain. And this is the part of your brain that's responsible for all of your involuntary controls. Things like breathing, blinking, digestion, vomiting, swallowing, blood pressure, all that's controlled by the medulla. Now, with that brief introduction, I think we have enough information to begin to take a look at one of these sheep brains. Here's one of our sheep brains. It is a real sheep's brain. The sheep's forehead would be here. This would be the right side of the sheep's head. This would be the left side, and the sheep's body would be in this direction. As we can see, it looks like the brain is wrapped in something, kind of like a white sheath. This is actually 3 layers of skin that cover and protect the brain, and we call these the meninges. The outermost layer of the meninges is called the Dura Mater. That's the tough, fibrous portion of the meninges. The middle layer of the meninges is called the Arachnoid Layer. It's thin and delicate, much like a spider web, hence the name, the Arachnoid Layer. And the third layer of the meninges, the layer that clings directly to the surface of the brain, that is known as the Pia Mater. As we turn the brain over, we'll notice that the parts of the brain, they look much different on the bottom than they do at the top. Towards the bottom of the brain, we have what is known as the olfactory bulbs. And the word olfactory means your sense of smell. So this is the part of your brain that picks up the smells from the air around us and lets us know what we're smelling, like, say, chocolate chip cookies or pizza or chicken. The second set of cranial nerves, which would be these, they're known as the optic nerves. The optic nerves connect to the back of your eyes and run through your brain until we get here, to what we call the Occipital Lobe. And that's where vision actually takes place. The 12 cranial nerves are the first 12 nerves that branch off of the brain and spinal cord. And as we move further back along the brain, they begin to get increasingly smaller. So they're somewhat difficult to identify. But one area that we can point out is located here in the center of the brain, and this is called the Pituitary Gland. To help us better see the pituitary gland, we will remove the capillary bed surrounding it. And this is the pituitary. The pituitary gland helps to control the release of chemicals throughout the body. We call some of these chemicals hormones. Now at this point, we're going to actually remove the meninges from the brain. And to do that, we're actually going to have to cut them off of the brain. So we're going to take our scalpel down the center of the brain towards the back of the head. We're also going to make a cut that connects the two halves in the center. And at this point, to remove the meninges, all we have to do is simply peel the individual sides back. And now we can begin to see the surface of the brain.
So how does the brain feel?
Great question. The brain itself actually feels much like warm, thick, cooked oatmeal. It's pretty soft, but it does stay together as a whole for the most part. As we can see, the brain itself is divided into two halves, a right half and a left half. The right half of the brain controls the left side of the body. The left half of the brain controls the right side of the body. That's why we say it to be cross-wired. The left portion of your brain controls the opposite side of the body. The right side of the brain controls the opposite side of the body as well. Now, we haven't removed all of the layers of the meninges, simply the Dura Mater. The other two layers are still attached to the brain itself. We'll remove the Dura Mater completely, and as we remove the Dura Mater, you'll notice that some of the 12 cranial nerves actually begin to tear off of the brain and spinal cord. Now, the Dura Mater translates into the tough mother. Take a look at how strong the Dura Mater is. And it's designed to keep germs off of the brain. Now, looking at the brain, we can see the three main divisions of the brain: the cerebrum, the cerebellum, and the brain stem.
How much of our brain do we actually use?
That's another really good question. Doctors and researchers vary in opinions as to how much of the brain we actually use, but it is agreed that we don't use 100% of the brain, and we don't use as little as 10%, as many people used to say.
What's the difference between a woman's brain and a man's brain?
The difference between a woman's brain and a man's brain is quite small. One of the main differences is size. A man's body tends to be larger than a woman's body, so on average, a man's brain tends to be larger than a woman's brain. It doesn't mean that one is usually smarter than the other. It's simply on average. A second difference is the size of a part of the brain known as the corpus callosum. The corpus callosum is the bridge that connects the two halves of the cerebrum. It connects the right cerebrum with the left cerebrum and allows for information to be exchanged between the two. And they say in a woman's brain, the corpus callosum is usually slightly larger than it is in a man's brain. At this point, let's cut the brain into halves and take a look at the corpus callosum. This area of the brain is known as the corpus callosum. And this is the portion of the brain that they say is a tad bit smaller in men and a tad bit larger in a woman's brain. This area of the brain, it looks kind of like a tree pattern, is known as the tree of life or the arbor vitae. And this pattern is typically found in the cerebellum. This is the medulla. And this portion is the spinal cord, which connects the brain with the rest of the body.
What are all the little lines going?
Good question. The white lines that we see are what we call white matter in the brain. The white matter would be cells that have more myelination, this area of the brain cell here. Whereas the darker colored areas are what we refer to as gray matter. Those would be areas where the dendritic connections are larger. We'll make one more cut into the brain, which will allow us to see a different cross-section. And we can once again see the white matter in comparison to the gray matter. You guys have any questions over any of the information presented in the dissection?
Where's your knowledge stored?
When we think about memory and things of that nature, those types of things would be stored in the cerebrum, the largest part of our brain. So this is where memories would be stored. As we learn something new, that information would be stored in the cerebrum, the largest portion of our brain.
Does our right side or left side control, like one side control our feelings and the other side control our actions?
Well, we have an area of the brain known as the limbic system. And the limbic system is one of the emotional control centers of the brain. And the limbic system is located a little more internally within the brain.
And on the outside, all the little lines, that's when you learn new things. So what
Well,
are they called?
that's a good way to think about it, but I don't want you to believe that every time you learn one new piece of information, a new wrinkle pops in on this side. As you learn another new piece of information, another wrinkle pops in. It's more kind of like a library. It's a storage system. One of the reasons we have wrinkles is to increase the number of times that a brain cell touches another brain cell. By increasing the number of times that a brain cell touches another brain cell, you speed up the rate that messages can pass within the brain. So that's one reason why we have these wrinkles. Now we'll do a little hands-on investigation of the brain. Again with that part. It's pretty soft, huh?
It's like a dead rat. Human body is so cool. Dude, that is tough.
Yeah, it's been ripping.